Okay, so if you missed class today because you were at music or because you just weren't paying attention, here is a little bit of what we were talking about. So talking about if we had a circle, we knew that this half of a circle is worth 180 degrees. But now we're talking about radians. So if we think about the radius of the circle, that would be this piece. If we were taking it and putting it around the outside, it would fit about 3.14 times, which would mean that this outside piece here is worth pi radians, and the arc must match the central angle, so that makes this central angle in here also pi radians. And then we started discussing what it would look like if the circle was on the coordinate plane. So we had a circle like that. We know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We go around in the shape of the letter C. Well, if we were starting here at this position on the circle, this position is worth 0. Okay, got interrupted. So as I was saying, it starts right here. That's worth 0 degrees. That is also worth 360 degrees. Because if you started here and you made a full circle around, so that full revolution, and you'd land right back there, so that would be 360. If you kept going around, it'd be 720. It'd be any multiple of 360 would land there. Just like over here, if you were over here, you have gone 180 degrees. So this top axis up here is worth 90 degrees, and this bottom one down here is worth 270 degrees. So that should make sense to you. This is 90 because, of course, you have a 90 degree. Here's your 180. You should see that. So now we're going to go back and fill it in as if it is radians. So here at this position, we are at 0. Or if we come all the full distance around the circle, so all the way around, we would be at 2 pi for radians. And that should make you think of circumference, because that circumference formula is 2 pi r. So that full circle is 2 pi in terms of radians. So in thinking of that, if we did half of a circle, then this over here, of course, is pi radians. If we did the 90 degree rotation there, that's going to be half of pi, because that's halfway to the 180. So this up here is your pi halves radian. And then down here must be your 3 pi halves for radians. Okay, so we've got that picture now. So we could be thinking, it might ask you, what quadrant would you be in if you went 70 degrees? So if you went 70 degrees, of course, you're going to be in quadrant 1. How about if you went negative 100 degrees? What quadrant are you in? So if you're going negative, you are working in reverse. There would be your 90, and you'd be slightly past to get to the 100. So you, of course, would be in quadrant 3. Or a lot of times you'll see they don't allow that negative. So if you're here at this negative 100, your line would be coming out here at that negative 100 degrees. You could also get to that same line by starting at the 0 and coming around in a positive direction, and that negative 100 would have the same value as a positive 260 degrees. We can also think of it in terms of radians. There's my circle again. All right, so let's say that I want to know what quadrant we'd be in if it was 7/2 pi radians. So you got to think about that, because coming all the way around to here, that is worth 2 pi to make that full revolution. So 2 pi would be worth 4/2 pi if I'm going with a common denominator, which means now I need to rotate 3/2 pi more. Well, we knew up here was pi halves. This was worth pi, and this was 3 pi halves. So once I've come around the 2 pi, I'd keep going, and I'd come back here, and this would be on the y-axis. Sorry, it's running off the paper there. So hopefully that helps you a little bit with your worksheet. Give it a try, and we'll talk about it in class tomorrow. We also have a quad check tomorrow, including 11.1, 11.2, 11.3, and the first radian worksheet.